right, so far we've dealt with an integral where I had a discontinuity as my lower bound. What we're going to be dealing with in this video is if I have a discontinuity as my upper bound. So at the end of this video, you'll be able to evaluate an integral with an infinite discontinuity at its upper bound. Alrighty, let's go ahead and see how we do. Alrighty, you'll notice we do have a theorem up here, but we'll go ahead and go to the example first so you can see what we're talking about. We'd like to evaluate the integral from 0 to 2 of ds over the square root of 4 minus s squared. Again, please notice that we could plug in 0 and get an answer. If we tried to plug in 2, though, this function would be discontinuous at 2, so that's what creates our problem. If you were to graph this function, it actually looks something like that. So you'll notice as we're approaching 2 again, we've got some issues. So what I'd like to try to find the area under the curve from 0 to 2. I just need to see if we'll actually get an answer or if this integral will diverge. So what we are going to do, you'll notice we're coming into the discontinuity this time from the left side. So we are going to, just like we did on the previous video, we're going to, instead of approaching the discontinuity from the right side, we'll approach the discontinuity from the left side. And sometimes it helps to draw a picture. We're heading towards 2, so we're coming in from 0 to 2, we're coming in from the left side. That will help you decide, should I come in from the left or from the right? So what we're going to do is replace our discontinuity, our 2, with the letter. So we'll be finding the limit as w approaches 2 from the left side, and then our integral will be ds over the square root of 4 minus s squared. This will go from 0 to w. Alright, so now we'll just go ahead and evaluate this integral. This actually is an arc sine setup, and if you can recall, we've got du over the square root of a squared minus u squared. That's equal to arc sine of u over a. So what we are going to do, I just need to identify my a would be 2, my u would be s, and then du is 1, which I have. So I have my parts all set up. So this is just going to be a straightforward arc sine u over a, so s over 2, and then I'm ready to evaluate it at 0 and at w. So if I plug in w, I'm going to get arc sine of w over 2 minus arc sine of 0. Okay, I can simplify this further because the arc sine of 0 is asking yourself the question, where does the sine value equal 0? And that would be at 0. And so we actually don't need that in here, so my answer is going to be arc sine w over 2. So I now have that as simplified as I possibly can. So now I need to find the limit of that as my w approaches 2 from the left side. Okay, so now if I plug in 2, I plug 2 in here, I'm going to get the arc sine of 1. And since I don't have to worry so much about the negative this time, because notice it actually ended up, it didn't give me infinity or something kind of crazy like that. So 2 divided by 2 is 1. We could plug 2 in and get an answer. So I'm now going to be looking for where does the sine value equal 1, and the sine value does equal 1 at pi over 2. So we are able to get an area under the curve for that, and it does equal pi over 2.